So in the previous lecture, we saw the four questions on the transducer, that is 10th unit of the UGC NET Electronic Science syllabus. So now here we're going to see the continuation of this one. It is the fifth question. So here the question is the list one, the bridges, and the list two are the applications. That means the which bridge is used to measure the which things here. So coming to the as per the lectures, I told that Maxwell's bridge and the Hay bridge, both these two are used to measure the inductance, right? But out of the inductance, Maxwell's bridge is used to measure the low Q values, and Hay bridge is used to measure the high Q values. That means high quality factor. So out of the given options, option A is matches to the medium Q values. Sorry, option B. Okay, medium Q values, and coming to the option A, Hay bridge is high Q values, right? And while coming to the Chering's bridge is used to measure the unknown capacitance. So here the C is matching up with 1, and Wien's bridge is used to measure the frequencies generally. So this one frequency. So as per this one, first Hay bridge is used to measure the high quality coils, high quality factor coils or the high inductance values. And while coming to the B, Maxwell's bridge is used to medium coils, medium Q coils or the inductance, and Chering's bridge is used to measure the unknown capacitance. Wien's bridge is used to measure the frequency. So here the order is 3, 4, 1, 2. That means option 4 is the correct one. So for the in detail operations and the expressions and all, you please refer the corresponding video lectures. And coming to the next question, sixth question. So here also the two lists are given, list 1 and list 2, and the list 1 the different transducers are there, and in the list 2 the corresponding applications are mentioned. So we will find out. So LVDT is nothing but linear variable displacement transducer, or else a differential transducer, so which is used to measure the displacements. And while coming to the dielectric gauge, so the dielectric gauge is used to measure the liquid levels. Okay, dielectric gauge is used to measure the liquid levels. So these dielectric gauges we can also use in the water tank indicators also. And coming to the Pirani gauge, so the Pirani gauge is used to measure the gas flow. How much amount of gas is flowing depends upon the pressure. Okay, so if the gas flow rate is high, then the pressure is also high. If the gas flow rate is less, then the pressure is also less. And while coming to the piezoelectric transducers are used to measure the accelerations. Okay, so piezoelectric crystal, the piezoelectric transducer is a active transducer. So here the A is matching up with the 2, and B is 3, and C is 1, and the D is 4. So here the first option is the correct one. And coming to the types of the transducers, as I told that the piezoelectric is an active transducer. That means we don't require any type of external supply. But while coming to all these three, LVDT, dielectric gauge, and the Pirani gauge, so all these three are comes under the passive transducers, which require some external supply to convert the one form of energy into another form of energy, or else to measure whatever the energy you want from these transducers. And now while coming to the second, next question. So it is a seventh question. Important elements of the cathode ray tube are given below: pre-accelerating anode, accelerating anode, focusing anode, and the heated cathode. So here they are asking to find out the correct sequence of the above elements in a CRT in the direction of electron beam. So while coming to the cathode ray tube, see it is a internal part of the cathode ray tube that you can observe here. So in this internal part, here the first one is the cathode, right? So the first is the cathode, and after the cathode, next is the pre-accelerating anode. After the pre-accelerating anode, focusing anode. Next one is the accelerating anode. So it is a procedure: cathode, pre-accelerating anode, focusing anode, and accelerating anode. Next one, the vertical deflection plates and the horizontal deflection system will be there, so which are used to deflect the electron beam on the screen at the desired position. So based upon this one, the order which we can follow is that The first is a D, right? That is a heated cathode. And after the heated cathode, next one is a pre-accelerating anode. And after this one, the third one is a focusing anode, and fourth one is a accelerating anode. After the accelerating anode, what are there? Vertical deflection system. Next one is a horizontal deflection system, right? Vertical and horizontal, and the final thing is a screen here. Okay, so these are the order actually. So here D, A, C, B, right? So the third option is the correct one, D, A, C, B. Okay, so to attempt this one, you must have the idea regarding the internal structure of the cathode ray tube. And coming to the next question. So the following statements are given for the electrodynamometer type instruments. So the electrodynamometer types of instruments are used to measure either only AC or DC, or to measure the power and frequency, or it has only one coil. So which of the given things are correct one? So we have to identify here. So it is the internal structure of the electrodynamometer. So in this electrodynamometer, we will be having the two fixed coils and one moving coil will be there. So from this internal structure, what we can understand is that totally three coils will be there in the electrodynamometer. Out of these three, two are the fixed coils and one is the moving coil. Okay, and based upon this moving coil, we are going to get the indication on this indicator or the meter scale. Okay, and whatever the terminals are there here. Okay, so this terminal is coming from this fixed coil and another terminal is coming from the other fixed coil. So whatever the thing you want to measure, you can apply that parameter. That means if you want to measure the voltage in the circuit at any one point, so connect both these 2 points to that point of the circuit, then it starts reading the voltage. So here the thing is that this electrodynamometer is used to measure both AC as well as DC quantities. Okay, it can able to measure both the AC and DC. So here the obviously the B is the correct one, and it is used to measure power and frequency also. Power of the signal and frequency of the signal, both these two can be measured. So generally the electrodynamometer is used to measure the AC and DC voltage and current. Okay, voltage and current, both these two we can measure with the help of this electrodynamometer. That's why it is a electrodynamometer is also called as a AC voltmeter or AC ammeter, DC voltmeter or DC ammeter. But with some little bit modification to this electrodynamometer, we can also measure the power of the signal and the frequency of the signal also. Okay, so that means the option C is also correct one. So A and D, both these two are the wrong one. So BC is the correct one. That means option 2 is the correct one for this question. And next, while coming to the ninth question, here a platinum RTD has a resistance of, that means the resistor temperature dependent has a resistance of 100 ohm at 0 degree centigrade. If the temperature coefficient is 0.004 per degree centigrade, what would be the change in resistance if the temperature rise is 50 degrees centigrade? So generally for the RTD, that is the resistance temperature dependent, the RT or else R of T is equal to reference resistance into delta T. So it is the formula. So what is this formula is that resistance at particular temperature capital T is equal to resistance at 0 degree kelvins or 0 degree centigrade into 1 plus alpha represents the temperature coefficient into delta T. That means the change in temperature. Okay. So with this one R of T, that means at which temperature he is asking to find out the resistance 50 degree centigrade. Right? So R of 50 degree centigrade is equal to, where R naught is nothing but a resistance at 0 degree centigrade. So here they given as a 100 ohm. 100 into 1 plus, where alpha is nothing but a temperature coefficient, that is given as 0.004 into delta T. Delta T is the change in temperature. So 50 degree minus what is the starting temperature? 0. So like this. So that is equal to 100 into 1 plus 0.004 into 50, that is equal to 100 into 1 plus. So after multiplication of 0.004 into 50, we will get 0.2. So finally that is equal to 100 into 1.2. So 100 into 1.2 is nothing but 120 ohms, right? That means the resistance of the RTD, of the platinum RTD at 50 degrees centigrade can be given as 120 ohms. That means at 0 degree centigrade it is 100 ohms, and at 50 degrees centigrade it is 120 ohms. That means if you increase the temperature, the resistance is also increasing. But because this concept is applicable for the PTT, okay, or else we can call it as a PTC, positive temperature coefficient resistance. Positive temperature coefficient resistance means if the temperature increases, then the resistance also increases. Okay, so it is a formula applicable to this one. So generally, if any one RTD is designed with metal, platinum is a metal. If any one RTD is designed with the platinum, then or the metals, okay. So metals is having the PTC property, that is the positive temperature coefficient. That means if you increase the temperature, the resistance will increase. But if the RTDs are manufactured with semiconductor materials, semiconductor materials are having the NTC, that is negative temperature coefficient resistance. That means if you increase the temperature, then the resistance will be decreased. So if the RTD is manufactured with the semiconductors, which is having the property of a negative temperature coefficient resistance, then the formula will simply changes as, instead of plus, here we will get the minus. Right? If the RTD is designed with the negative temperature coefficient resistance property materials, just like the semiconductors, then here I will get the minus. If the RTD is manufactured with the metals, which are having the positive temperature coefficient resistance, then I will get the plus here. Okay, that is only the difference I want to say. Okay, so these are all the questions that we faced in the June 2019 regarding the 10th unit, that is the transducer. Thank you.